Okay, it's 1 o'clock. Let's get going. Welcome, everybody. Robert looks sharp today. Welcome to another clinic. Let's see. We just go through the usual motions, which means I'm going to pause and ask, are there any questions at this point? I checked our Google document, there weren't any, and but there might be.
Gerd, there was a question if VFD SWMR, this new version, supports.
Yes, and I have that for tips and tricks, and we can quickly jump there. We had actually a code review meeting on Friday, and John was here or was present at that meeting, and we discussed this question with him, and he said it is untested. However, it should not be an issue in principle, because it's so the VFD SWMR implementation is so low level, it doesn't interfere with the free space manager, so it should work. So which means that this problem should magically disappear. I mean, performance might be bad for other reasons, but this problem in principle does not exist with VFD SWMR. So we will see if we will test it and see if it's really true and works. But yeah,
I checked with him too, so that's why I jumped in. But I think what is important to emphasize that still what it means, library takes free space and it will reuse it. It may reuse it when next time file is open, but really if you're trying to save space, this is the not only solution. This is how you write, compression you use, size of chunks. There are other many factors that will probably will have bigger impact.
And also with the old approach, so to speak, it's really the overly aggressive flushing, not utilizing the chunk cache. That's really the main problem. And sure, if that's what your workflow does and you can't change it, well, then you are stuck, unfortunately. And okay. Good. Yeah. Okay. Good. We can check the box there. Any other questions?
No other questions, Gerd. But thanks for the link on the indexing system of pi tables that you put on the forum. That was very good. Very useful. Thank you.
Yeah. And that is really, I mean, of course, Francesc, who worked on this, is very active in the community, and you can almost see a red thread between this work and the work that he is currently doing with BLOSC 2, although not literally, but sort of his thinking of cache awareness and multi-threading and so forth is really a lot of those ideas, or he probably thought about a context like this when he put this OPSI work together. And to me, it's one of the, if you want to explain to, and actually we'll come to it in a moment, if you want to explain to someone, well, how would I, out of the box, HDF5 does not support any kind of querying or indexing, how would I even go about doing that with some effectiveness? And this paper, to me, is really sort of the canonical answer, or sort of, can you improve on that? Yeah, in different application contexts, perhaps, but it's sort of, it's very well presented, and it's a great paper. Okay, good. Well, let's jump right in. I'm just going to mention one more time, VFD SWMR Beta 2 is out, but on our next topic, we will see that will be baked in to the sort of main development branch fairly soon. And so, which brings us to the second item, the HDF5 release schedule for 2022. This figure is also, I might have shown it in the past, is available if you go to GitHub, to the HDF repository. It's sort of down near the bottom, not because we want to hide it, but it's just there's plenty of other content. So it might get updated periodically, but this is the current version. So the high-level message is, and for those of you who subscribe to the newsletter, I think you will have gotten a newsletter maybe yesterday that had similar information and a reference to Dana's blog post. Okay, so the big message here is, okay, well, first of all, different colors obviously represent different mainline releases, sort of reddish 1.8, yellowish or olive 1.10, bluish 1.12, and then greenish 1.13, meaning develop. And then here we have 21, 22 broken down by month. And yeah, according to our current planning, 2022 is going to be the end of the line. There will be one more 1.8 release, and it will be 1.8.23 because 1.8.22 is out. We released that in February. And so there will be one more 1.8 maintenance release. We released 1.10.9 a few weeks ago, and that will keep on going. So there will be another 1.10 release early next year, most likely. 1.12 is coming to an end as well. So the current 1.12 release family stands at 1.12.2, and there will be 1.12.3. But after that, that's the end of the line for 1.12. And then as far as develop goes, there are certain major use cases or features under development at the moment, so they will get merged into the current develop branch 1.13. And so I listed them here. It will come in two steps, so there will be two more 1.13 releases. One is 1.13.2, and that will bring, and that's targeted probably the end of this month, so late July, early August. That will include Selection IO, VFD Swimmer, and the Onion VFD. So that will make 1.13.2. And of course, there is testing going on right now, but then of course, yeah, there will be more testing in this sort of more integrated development branch. And then 1.13.3 will pretty much bring two more features that we want to release eventually in 1.14.0. It will bring multi-dataset I/O and subfiling, and that's going to happen probably late in September, early in October. And then pretty much between October and December, we will sort of stabilize or resolve any issues that may have come up with bringing in all these major features. But assuming everything goes well, the testing goes well, there aren't any major other issues, then we will release 1.14.0 in late December or early January, depending on how things go. Now, you might ask, well, why are we doing that? Why are we sunsetting 1.8.23, or why are we sunsetting 1.12? So there are specific reasons, but there are also general reasons. The general reason is, of course, for a small organization of our size, the more releases we maintain, the higher the cost. So it's pure and simple economics. Having 4 releases rather than 1 or 2 is a lot worse. Elena.
Yeah, I just have a question about Selection IO. Is it real Selection IO or it's still Vector IO?
That's an excellent question. I do not know. I don't
because
know.
I believe Selection.io will change public APIs for VFD layer, right? And then, yeah, so there will be compatibility, which is important.
Yeah, but I would hope that those changes would be in, because once this is baked into 1.14, we don't want to then,
right.
yeah, sort of make other changes. Yeah.
Right. And the second is, does it mean that there will be improvement in 1.13 for performance to reach some kind of threshold of 1.8?
Yes, yes. So this is the goal. I actually skipped over it. Yeah, I wasn't paying attention to my own notes here. Yes. So over the summer, which means starting probably middle of July, and then for about maybe a month and a half until the end of August, there will be a, call it a performance push, or well, first an analysis before we start pushing, where we will try to pretty much recover any known remaining performance ground that we lost going from 1.8 to 1.10. And so those changes will first of all go into develop, so into 1.13, and they will also go into 1.10. Because a lot of people depend on that. And just as a reminder, if you ask, well, why not keep 1.12 alive rather than 1.10? Well, one of the biggest difference, or in a way, the most important difference between 1.10 and 1.12 was the introduction of the virtual object layer. So 1.8 and 1.10 both do not have the virtual object layer. So in a way, 1.10 is really an evolutionary step on 1.8. I mean, it introduced 64-bit identifiers and SWMR and virtual data sets and so forth, so that there are quite a few new features, but it did not have this virtual object layer as an extension. Whereas 1.12 introduced that. Now, of course, since the introduction of 1.12, there have been actually quite a few virtual object layer plugins that were developed. And of course, we learned a lot. The people who developed these plugins and we, as the maintainers of this virtual object layer interface, learned a lot along the way. And that, in a way, prompted the introduction of 1.14, which in a way is mostly driven, definitely by performance. Performance is always a factor, but basically to revise the virtual object layer interface based on the lessons that we have learned with 1.12. And so that's why it makes no sense to, if you do vol development, for example, today, you wouldn't do that in 1.12 because the sort of the state of the art, or the best interface, the best vol interface in the sense at the moment is really in develop. So if you were to develop a vol plugin, you would definitely do that against develop. But then, yeah, come, let's say, January, you will have an official release with the next generation vol interface baked in. And so that's kind of the reasoning behind this. And yes, so the performance improvements will be made over the summer, and those performance improvements will go into develop in 1.13 and then into 1.14. But they will also be, as far as they are applicable, be backported to 1.10, and then so the 1.10 line will continue. For people who say, I don't need vol, or they might have other reasons that they say, I don't need SWMR VFD, I don't need all these other things that will be coming with 1.14. Okay, good. Another interesting thing, Lori, I think she just created a new rubric or category in the forum, and yeah, we just posted 2 job announcements that had been out there for some time, but we also would like to encourage people who read the forum, who work for companies, who are looking for HDF expertise and so forth. They are welcome to use that as well to, in a way, reach out to people that had quite a bit of exposure to HDF5 and they're looking for talent and so forth. So it serves our purposes, but we also want this to be like a job board for skill sets that require quite a bit of HDF experience. And in addition to the official job postings, so to speak, generally, if anybody is interested, if they think I like HDF5 or I find this kind of work interesting and so forth, send us your resume. We may not have a position immediately, or then it depends on, where do you see yourself fit? Not everybody here is a developer. I mean, we have people working in outreach, working with application teams and so forth that do not work directly into the library. And then there is, of course, the whole cloud HSDS side and so forth. So if you think this kind of work is for you, send us your resume. Okay, next. There was an interesting blog post by John, Mr. HSDS, as I like to call him, and I just quoted here a paragraph or 2 sentences or 3 sentences from his blog post where he says he is working with this collection of HDF5 files or domains, as he calls them, and each is about 1 terabyte in size. And if you wanted to download them on an 80 megabit connection, that would take about a month. But then let's assume you would like to retrieve, this happens to be sort of geolocated data. You're just interested in one location, but you would like to retrieve some data specifically for the available time frame, which is sort of 7 years here. How long would this take? And it turns out, I think in his blog post, he has some suggestions, but I think it takes less than 10 seconds in the end. For one implementation, I think it took 7 seconds, and for the other, even 3 seconds. And as the title suggests, it's got to do something with multiprocessing and asynchronous processing and so forth. So interesting read and relatively short, so shouldn't be too long. Okay, before we jump to the forum, any questions? No? Okay, then let's press on. Okay, so this was rather open-ended. It was actually a question that had come up a long time ago, and then somebody replied again to it, so it just popped to the front of the queue. I'm just quoting here the original question that the user asked. He said, okay, I have a 500 gigabyte keyed table, and he would like to somehow store that in HDF5, and then he would like to retrieve rows matching specific keys, so using certain criteria where, okay, he says it's a table, which I think he implies that, okay, that's some kind of compound type where you have field names, and then when he says keys, he probably means columns or key column names. And then he says, well, it appears that if you wanted to do this in HDF5, he would have to somehow construct a mapping between like a field or certain field values and the corresponding indices or row numbers, if you wish, in the data sets, assuming you store all this in a single compound data set in HDF5, and you would have to maintain that somehow outside of HDF5. And then he asked, well, isn't retrieval more efficient with a distributed system like Spark, which uses HDFS? Again, the problem here is that, this is a very open-ended question, and without additional context, there isn't really much one can say. I mean, just to reiterate, out of the box, there are no querying or indexing capabilities built into HDF5. If that's the question, the answer is no, there is no such thing. And sure, you can put it into a data set with a compound type, but I don't know if you would win anything or what you would win. You would then have to look into things like, for example, compression. Okay, is the data compressible? How compressible it is? Is it actually a good idea to use one compound type rather than some kind of columnar layout? That would be another question. Another question would be that ingest process. You could certainly try to do some kind of sorting during the ingest process. So would you just store them in the order, in the original order, or would you try to do some kind of pre-sorting? So when the data arrives in the HDF5 file in whatever representation you chose, you've actually sort of done some kind of pre-indexing or coarse indexing or even partitioning or something like that. Now, so generally speaking, can something like that be, that meaning querying and indexing capabilities, be implemented on top of HDF5? The answer is yes, of course. It's been done many times, but it's been done for very specific requirements. And yeah, because otherwise, if you want to implement this in a very generic way, well, then you could ask, well, why don't you use a database or a SQL database or a NoSQL database? If you want a generic capability, then just go use those. There's really no point in doing that with HDF5. But then the question is, are other tools necessarily more efficient? Maybe, maybe not. So the user mentions, for example, Spark. Well, that depends on, for example, the deployment, the number of clients, and so forth. First of all, Spark is really just a compute engine. Spark is not a storage manager or something like that. And yes, you can use Spark with the Hadoop file system, but you can also use Spark with S3 or with relational databases. Spark doesn't really care where the data comes from. So are there certain providers or connectors for Spark for specific storage types? Yes, there are. And they can do things like filtering and push down predicates and things like that. But again, this is all a question of what is the data about, how do you plan to use the data, and so forth. And depending on all of these factors, maybe a Spark solution out of the box is faster, where you would develop something by hand with HDF5, maybe not. And yeah, as Robert commented earlier, if you want to just get some clues about what you could do with indexing, read that paper by Francesc about how they implemented indexing in PyTables. And and then of course there are still the generic indexing. I mean, indexing, if you want to go down that path, it typically involves either some form of B-tree or it involves hash tables. And there are plenty of other options. So I remember a project at Berkeley where they implemented, I forgot if it was called H5 index. It was developed with bitmapped indices in the context of visualization applications. So there is plenty of existing work. But yeah, for us, it was never, we could never make a compelling case to implement or provide some generic indexing capability in HDF5. And I think that thinking hasn't really changed fundamentally because it's just such an open-ended thing that, yeah, the compromise maybe to make it more generic or make something more generic that then doesn't really get much use and complicates the library or the software in general is maybe just not a compromise that we want to make. Okay. Then there was another that was sort of a good one because it relates to something we talked about in the past. Someone noticed a Initially, they thought it might be related to NFS, but then it turns out it's actually not related to NFS. But they noticed that, yeah, they have an application that uses 1.8, and then when they switched to 1.10 or 1.12, there was a dramatic drop in performance. And then, yeah, I think the user in his initial post speculated maybe it's related to NFS, but that turned out not to be the case. It also was the same problem when running against a local disk or something. So we do what we always do in this case. Let's understand sort of what is the long pole in the tent, and if you're lucky, you will find it. And he was able to find it easily using, for example, a profiler like Google Performance Tools. He found that when he compared the version based on 1.8 with the versions on 1.10 or 1.12, he found that these slower versions spent about 85% of their time in this function H5F get object count, and this is something we've seen in the past. This is so this is basically a function that you can, in a way, inspect the open what the library thinks, how many open objects it has, data sets and attributes and whatnot. And it also turns out the user didn't tell us that this was a Fortran application, but then he correctly inferred that it seemed to somehow be related to the frequency of sort of initializing the library and shutting down the library. And that was actually, and he found that, I guess, by just searching the forum. A while ago, we discussed an issue where a user reported that they were sort of getting very inconsistent results from the Fortran wrapper of this function. And it turns out, yeah, Scott Breitenfeld at the time provided a quick fix literally within a day because, yeah, in the implementation of the Fortran version of this function, the library in this implementation lost track of the correct count of open objects and so forth. And so that was fixed. And then this user here then applied that fix to, because I believe we have not released that. I mean, the fix is in the 110 and 112 branches, but since we haven't had a release since Scott fixed it, the official releases of 110 and 12 are still suffering from this issue, but they won't anymore once the next release rolls around. And so he made that patch, and lo and behold, yeah, performance is back to normal and at 1.8 level in this case. So that's good. And happy ending, well, almost. And yeah, I mean, things are good for this user, but there was something odd because in the conversation, we asked him somehow, well, okay, how many data sets and whatnot do you have? And we just asked him by sort of, yeah, that's just a good thing to always ask is, well, have you run H5stat, which gives you pretty much an overview of the file space allocation and usage and utilization and whatnot. And it turns out that when I looked at this at near the end, you get sort of this file space breakdown, if you wish. And I noticed, well, that looks really odd because what this tells us is that we have about a megabyte of metadata in one of these files, and sort of the raw data associated with that is less than a tenth. And that's when you see that, that's whenever you see something like that, that's kind of, you say, well, that's odd. Why would that be? Why would it be for a given piece of raw data, as people call it, like a number, a small array or something like that? And then sure, there is sometimes metadata associated with this. But typically the data to metadata ratio is, or the other way around, the metadata to data ratio is tiny, is very small. So, so it would be less than 10% typically of your file space should be occupied by metadata, probably less than 1% in many instances. And so it turns out that he was using chunk data sets, and in several of these chunk data sets, he used a chunk size of 1. And of course, that explains where this is coming from. And because that just means that the chunk index, the B tree in this case, we didn't talk about which version of the specification he uses, but assuming he uses the earliest version, yeah, the B tree that keeps track of the chunks, well, those chunks consist of a single data item, let's say an integer or floating point number and so forth. And yeah, that overhead is just tremendous in this situation. So yeah, he will look into choosing a larger chunk size, because then you can amortize the allocation cost. You can still sort of dynamically change your extent and so forth, but you amortize, you allocate that chunk that you then populate over time, and that will hopefully remain in the chunk cache while you are sort of generating new entries. So that was a good one. And we are out of time. I'm still puzzled by this, and I will have to say more at the next meeting. This issue with these memory-backed files where the user thinks there is some kind of things seem to be fine in 1.8.17, I believe, or in a 1.8 version. But then I haven't asked him about 1.10, but in 1.12, he says that either it's not working or there is a tremendous slowdown. So it's not quite clear yet what's going on. And unfortunately, I personally haven't had the time to sit down and dig a little deeper, but I hope I will find that time between today and the next meeting. And then we'll come back to that. Okay, thank you. Sorry, I didn't, if there are any questions, put them down in the Google document and we'll do them first things next time. All right. Thank you. Bye.
Thanks, Gerd.